A solid sphere of mass m and radius r and having moment of inertia about an axis passing through the center of mass as I. Okay, so we have a sphere, solid sphere, and there is a axis passing through its center of mass. This is m mass and radius is r. Okay, and moment of inertia about axis passing through center of mass is I. Okay, so now what will be this moment of inertia? This is solid sphere, na? So this will be I is equal to 2 by 5 mr square, because this is a solid sphere. Now what is the moment of inertia of the disk of thickness t? Okay, there is a disk. The disk thickness is t. Thickness of disk is t. Now the volume of this sphere and the disk will be same, right? So that means 4 upon 3 pi r cube will be equal to pi r1 square. R1 is the radius of the disk. We don't know the radius. R1 square into the thickness t. Pi and pi gets cancelled. So this is 4 r cube by 3 is equal to r1 square t. Okay, let's see what we can do with this. Okay, whose moment of inertia about an axis passing through its h and perpendicular to its plane remains I. Okay, so now this moment of inertia is given to be I. See, what is this moment of inertia about an axis passing through its edge? Okay, this is passing through its edge and perpendicular to its plane. This is the plane, so it is perpendicular to the plane. This is I. So now what is this I? Obviously, what is this one? This moment of inertia. This is m r dash square, sorry, r1 square by 2. M r1 square by 2. And this distance is r1. So we can use a parallel axis theorem, right? So I is equal to m r1 square by 2 plus m into r1 square, right? So this is m, see, half plus 1 is 3 by 2. So this is 3 m r1 square by 2. This is the moment of inertia, right? Now this must be equal to this one, right? So that means 2 by 5 mr square is equal to 3 by 2 m r1 square. So m and m gets cancelled. We have 4 by 15 r square is equal to r1 square. So r1 is equal to 2r upon square root of 15. 2r upon square root of 15. That is A option. A option is the correct one.